And example problem 2 is multiple choice. An architect drew the sketch of a bridge shown below. The bridge has 12-foot long horizontal members and 24-foot long vertical members. What is the length in feet of each diagonal member? Round to the nearest foot. Well, in this section we're using the Pythagorean theorem, and recall the Pythagorean theorem applies to right triangles. So what we should attempt to do in a problem like this is to isolate a single right triangle, label its leg lengths, and use those and the Pythagorean theorem to find the hypotenuse length. So at the right, I've drawn a larger view of a right triangle for us to represent each of the right triangles in this the sketch of the bridge. Note we know the leg lengths. It's probably true that the 12-foot leg is easier to recognize. The 24-foot leg, note that represents the height of this structure. And when considering the right triangles, that represents this leg. Leaving us the hypotenuse, which I'll label C here, as our unknown value. To complete this work and find our solution, we now apply the Pythagorean theorem. We let one leg be A, we let the other leg be B, and we let our hypotenuse remain C, our unknown value. And much as before, we will write out the equation a squared plus b squared equals c squared, and in this case, substituting in our values, we'll find 24 squared plus 12 squared equals c squared. Okay, 24 squared, well, 24 times 24, I'll find some scratch paper up here. 24 times 24, 4 times 4, of course, 16. 4 times 2 is 8, plus 1 is 9. Add our 0 for a placeholder. 2 times 4 is 8. 2 times 2 is 4, and this was from earlier, the 1 that was carried. 2 times 2 again, 4. Adding 6, 17, 5. 576. Now 576 is beyond the scope of the list of perfect squares that I typically list, and it's also not one that I have memorized. And so it's okay to use scratch paper to do the quick multiplication. 12, on the other hand, should be memorized at this point. 144, 12 squared equals c squared. And now summing these two, I'm going to use some more scratch paper. 576 plus 144, 6 plus 4, 10. 7 plus 4 plus 1 more, 12. 5 plus 2, 7. 720. So 720, that was the sum resulting from this addition, equals c squared. And now it's time to use some algebra to perform inverse operations. And again, the inverse of squaring is to apply the square root. The square root of c squared leaves us with just c equals the square root of 720. And 720 is not a perfect square, and so we're allowed to use our calculator to approximate it. Here's my handy dandy floating calculator. Square root of 720. On this calculator, in order to access the square root button, whoops, accidentally clicked the square root key, I need to hit second, and then the x squared key, which becomes square root. There we have the square root of 720, and I don't need to close the parentheses. If we were continuing and performing more operations to the square root of 720, it would be very important to close the parentheses so that the square root wasn't applied to the rest of the expression. But since we're not, I can get away with deleting that. So to show you, when I tap enter, 26.832, but in this problem, recall we are told to round to the nearest foot. So rounding 26.83 to the nearest foot, that's going to be 27 feet. So thank you, calculator. Approximately 27 feet. So you can see also a nice sentence written for us. Be sure to use complete sentences and include units. The length of each diagonal member is about 27 feet. Also important to state about, because it's not exact. Remember, we rounded. So about 27 feet. That leads us to the answer choice B. And now that I think about it, a multiple choice question, you wouldn't be required to write a nice complete sentence. Once you identified the correct choice, you could select it, unless the directions said otherwise. And how about a couple quick check problems to make sure you're understanding the material from these examples before you move on. Number 1, find the length of the hypotenuse of a right triangle with legs of 12 centimeters and 16 centimeters. Work carefully, and I recommend a sketch. Draw a sketch on scratch paper or a whiteboard or an iPad app to help you recognize the legs and the hypotenuse and set up your Pythagorean theorem equation. 2. A bridge has 22-foot horizontal members and 25-foot vertical members. Find the length of each diagonal member to the nearest foot. So I think it's safe to assume that this bridge has the same structure as we saw in example problem 2. So refer back to that if necessary to construct your right triangle, identify legs, and solve for the hypotenuse or the diagonal member.